The exponent concept that I want to talk about in this lesson is zero and negative exponents. And we have to be careful because zero exponents really have very little to do with the number zero, and negative exponents have very little to do with negative numbers. So think back to your mad spam rules. How would you simplify x to the third divided by x to the third? Well, mad spam says that when you divide, you subtract the exponents. So this would be x to the 0, because 3 minus 3 is 0. But I want to pause for a second and go off track for a little bit, and then you'll see where I'm going with this. I want to reduce the fraction 5/10. Well, we all know that that reduces to 1/2, but let me show you why that happens. 5 over 10 is the same as 5 over 5 times 2. And if there's a factor on the top that's also on the bottom, you can cancel them out. So if the numerator and denominator have a common factor, they eliminate each other. And when nothing's left on top, we put a 1 as like a placeholder in a fraction. So let's go back to this, and now I want to write this out the long way. So let's write x times x times x, and then x times x times x is the denominator. So if there's something on the top that's also on the bottom, they cancel out. So everything cancels, and you're not left with 0, though. What you're left is 1 divided by 1, because as I just told you, when everything cancels in a fraction, you put a 1. Well, 1 divided by 1 is 1, and this is the concept that I want to talk to you about, that x to the 0 equals 1. In words, that says anything to the 0 power equals the number 1. And let's just make up an example. Let's say 4 to the 0 is 1. All right, let's check out some examples. 0.35 to the 0, well, anything to the 0 power is 1. Doesn't matter what the base is. In order to do this, I have to do the mad spam rules. So when you have multiplication, you add the exponents. So that gives me negative 8.5 in parentheses, and negative 4 plus 4 is 0. So now you see that anything to the 0 power is 1. Now you can't get too comfortable because you still have to follow the order of operations. So order of operations says exponents come first. So the first thing you do is x to the 0. So you have negative 5 times 1, because anything to the 0 is 1. Now the answer here is negative 5. So don't assume that just because you see a 0 exponent, the answer is always 1. It's not. If there's any sort of order of operations involved, you probably will not get a 1 as your answer. All right, let's think back to mad spam. How would you simplify x to the 4th divided by x to the 6th? Mad spam says that when you have division, you subtract the exponents. So I get x to the negative 2. Let's see what that means. I want to write it out the long way like we did on in the other example. I've got 4 x's on the top and 6 on the bottom. Anything on the top that's also on the bottom can eliminate. And I don't have anything left on the top, so that leaves me with a 1. And x times x is left on the bottom, and that's x squared. So this is the concept I want to talk about now. What do negative exponents mean? Well, if you notice, this exponent is kind of the same as this exponent, only this one's positive and this one's negative. And the base kind of looks the same, x in both of the bases, but this is a fraction and this is not a fraction. So let's write that down in our algebra box. X to the negative 2 equals 1 over x to the positive 2. So what I've done is I'm taking the reciprocal of the base. So if the base is x over 1, then its reciprocal is 1 over x. Let's write that out in words. Do the reciprocal of the base, and again, 1 over x came from x over 1, so if there wasn't a fraction, I did it. Notice that the fraction is in parentheses now, and then the exponent turns positive. So once you flip it, then the exponent goes from negative to positive, and then you've done it. Let's make a quick little numbers example. 5 to the negative 2. Well, that would be 1 over 5 to the positive 2, because 5 is 5 over 1. And now if I wanted to actually evaluate that, it would be 1 to the second, which is 1, over 5 to the second, which is 25. So each piece inside the fraction gets the exponent, and that's why we use parentheses. Let's try these in some examples. So first we have to write it using a positive exponent, which we are learning, and then we'll evaluate, which again means to solve. So let's rewrite 3 over 1 as 1 over 3 to the fourth, and then each piece in the fraction gets the exponent. So this is the first half of the directions, writing it with a positive exponent. Now I need to evaluate. So 1 to the fourth is 1, and 3 to the fourth is 81. So that's the second half of the directions. In letter B, you have to use your mad spam rules first. The base is 2, and you subtract the exponent, so that gives you negative 2. Don't do bigger minus smaller like you did in first grade. The order matters. So 6 minus 8 is negative 2. Now we have to write that using a positive exponent. So if I put the 2 over 1, I get the fraction 1/2 to the positive 2. That's the first half of the directions. And the second half asks me to evaluate. So 1 to the second is 1. And 2 to the second is 4. There's a little bit to do in letter C before you get a final answer. It's not as quick as the other two, because you have this 9, which is essentially 9 over 1. But you have to do exponents first, because that's order of operations. So I'll worry about the 9 over 1 in a moment. First I'll do this part. So I get y to the negative 8. If you don't know your integer rules, this is going to be very challenging for you. And then I have 9 over 1 times y to the negative 8. I still have to do my exponents because I have to make it positive. So that gives me 1 over y to the 8th, and then bring back the 9 over 1. So I've rewritten it with a positive exponent, so technically this is finished. But now I have to kind of evaluate. Well, I can't really evaluate all the way because I don't know what y is, but I can simplify a little. So I'll rewrite this piece right here as 1 over y to the 8th, because 1 to the 8th is 1, and y to the 8th is y to the 8th. And then I can bring back the times 9 over 1 and simplify a little. So the best simplified answer is 9 over y to the 8th. All right, let's check out this real life application. A drop of water leaks from a faucet every second. How many liters of water leak from the faucet in 1 hour? So I've got seconds, I've got liters, I've got hours. Well, how many seconds are in an hour? So 1 second, 60 seconds is 1 hour, 1 minute, and 60 minutes is 1 hour. So how many seconds are in an hour? Well, that's 3,600 seconds per hour. Okay, so now that I know that, now I can solve the question a little more. And this makes me think of 7th grade proportions. I get 50 to the negative 2 liters in 1 second, and I want to know how many liters that is in 3,600 seconds. So let's do it. I'm going to cross multiply because that's what you learned back in 7th grade. So I get 1 times x, which is 1x, and then I'm just going to write this 3,600 times 50 to the negative 2. So now I'm going to treat that like I did in the earlier example, letter C. And I'm actually going to erase this one because it just looks weird to me, just X. All right, so I'll treat it like I did in the earlier example, and I'll rewrite this as 1 over 50 to the positive 2, and then bring the 3600 times. 1 over 50 to the second is 1 to the second, which is 1, and 50 to the second is 2500. Bring back the 3600 times. Well, I can put this over 1 and do 3600 over 2500. And when I do that division, I get 1.44 liters, which is why your parents probably hate when there's a drip, because every hour they're losing a lot of water. Think about dumping about 1.5 gallons or 1.5 liters of water down the drain every hour. That's a lot of water to waste. If you have any questions, write them down and ask me when you come to class.